I know the first lecture after dinner is always the hardest. But I think we can start. Yeah, I think we can. So it is my great pleasure to lead this last session today about analog missions. Can we start?
Yes.
Yeah, so Caroline, the floor is yours.
Thank you. Just click this. Just to launch it, I don't want to mess this up. Oh, yeah. All right. Let me just check that it's working. That's a really good point. Yep. Yeah, now it's working. If not, I can just do it on. I'll do it on the computer if you want. Thank you. Right. Good afternoon. I'm Carole Dangoisse. I'm very, very happy to be here. Incredibly grateful. I want to add, actually, my grandfather is Polish, so this has a very special meaning for me to have been invited here in Varsovie. So a huge, huge thank you to Carolina and the organizers. So this is going to be very much a picture kind of focused personal experience. My views are absolutely my own, and I don't represent any organism. Just an extra little touch. I have discovered recently that you have two stations in Antarctica. You have Arctowski, which is in the peninsula in the north on King George Island, and named after, quite interesting, named after one of the first scientists to winter over in Antarctica on the Belgica ship, and I'm actually Belgian, so nice tying of everything. And you've recently had a big symposium of COMNAP, which is the committee which kind of oversees all of the research in Antarctica. So you do have ties, quite nice ties. Now, I will speak to you about my winter over. I was the ESA research doctor in 2017, so it's been a few years, but things don't change too quickly down there. But this is a bit of a brainstorming kind of exercise that I've had over years now of lessons that I've learnt from my winter over. They're also kind of feeding into this winter over. I went there, I'll admit, I was very, very naive. I didn't know much about wintering over, certainly didn't know much about kind of team dynamics and space medicine. I'd always been passionate about space, but learned a lot more when I came back. So similarly to a few people in the audience, I have a certificate in space studies from the International Space University. I have an advanced course in aviation and medicine course from King's College, and I've completed a master's in medicine in extreme environments at the University of Exeter. And I've actually been back to Antarctica for ESA as well, but for 2 months, visiting the Argentinian stations to conduct more research for them as well. So quick kind of whiz through, and I'll be honest, I could probably speak for hours. It's very, very difficult to condense kind of a whole year in Antarctica in just 15 minutes and lessons learned. So please do stop me if I go over, and we can, speak after, or please do come and get me outside of the sessions. So first, I'll explain why is Concordia such a high fidelity analog. I'll speak a little bit about the technical, logistical challenges of conducting research there, the kind of medical preparation that you need, medical support, and then I'll touch on mental health and team dynamics in isolation. Let me see if my pointer works. So just for those of you who don't know, there are 3 inland stations in Antarctica. The majority are actually along the coast. There are only 3 inland. You have Amundsen Scott, that's at the South Pole, kind of in the middle there. You have Vostok, which is the Russian station. which is about there, and then Concordia, which is the only station that's actually dual citizenship, kind of, and actually triple. It's Italian, French, and then the ESA research doctor who can be from any European nation. So we are even more isolated than the coastal stations. My trip to go to Concordia, so I flew Paris to Singapore, Singapore to Christchurch, down here, and then had a Hercules flight to Mario Zucchelli, which is the Italian coastal station, landing on the sea ice, and then a Basler flight to Concordia. That was 5 hours, and this is about 6 hours. And then the return was a lot longer, so that was about 3 or 4 days, all in succession. I was quite destroyed when I arrived, and then on the way back, I flew a Basler to Dumont d'Urville. There's actually a skyway that's about 5 kilometers, then a helicopter to Dumont d'Urville where I stayed for a few days, then another helicopter to the icebreaker that was 40 kilometers away from the station because the sea ice hadn't broken during that summer, which actually has huge repercussions and seems to be happening more often and really prevents the boats from unloading and getting all the supplies. So during my whole winter over, that had been the issue in previous years as well. So it kind of hung over us that we hoped we had enough fuel for the winter, but it wasn't absolutely guaranteed. And so yes, helicopters to the icebreaker, and then 1 week back to Hobart, and that was through the roughest seas in the world, and I don't really recommend. So why is Whitemar such a good space analog? It's strikingly similar actually to a deep space mission. It's the most extreme environment that you can find on Earth. So yes, it gets to minus 50 in the winter. That's the mean temperature, but we went down to minus 83.6, and that's without the wind chill. And yes, you are still expected to go outside and carry on with your duties. You're obviously well protected, but that's biting cold. Lots of wind, lots of whiteouts. There's the polar night, so 3 months from May to August where you don't see the sun, but you still see obviously dawn and kind of the light, a little bit of light, but it's about 1 month really of kind of pitch blackness. You're isolated with, there were 13 of us for my winter over, and you need to be completely self-sufficient. There's no rescue, whatever happens. So during my winter over, 2 of us were actually doctors so that we could help each other out if anything did happen. And that's even in the case of death or severe illness, you are on your own. There have been a few rescue missions to some of the stations. There was one in August actually to McMurdo, which is the American station here on the coast. About 10 years ago, I think there was one to Amundsen Scott, but you have to understand that these took weeks to organize. They were extremely logistically complex. They were not quite suicide missions, but the stakes were incredibly high. The planes had to land, in the darkness, on ice, which hasn't really been groomed as it should. And they had to do kind of hot refueling, so keep the engines running, kind of load the injured people and then take off straight. And we have been assured that the same would not happen at Concordia because we are also at 3,200 meters altitude. So the atmosphere at the poles isn't quite as thick as it is at the equator, so that's actually about 3,800 meters. And so that makes it even more difficult to land. So we are on our own for 9 months. And I can assure you that when that last plane goes, you wonder if you've made the right life decisions. It's a bit of an awkward moment for everyone. So yeah, again, closest station is Vostok, 600 kilometers. I don't need to explain that kerosene freezes by minus 50, and people wouldn't survive doing that trek. We're on the plateau. It's completely white for miles on end. So you're very much restricted to the station as well. Like I said, we are allowed to go outside, but you, during the winter at least, you need to go in pairs and have walkie-talkies and never, ever, ever lose sight of the station because you might not be able to find it again. And boat rescues are not possible. You can see this is satellite imaging, and the whole continent is surrounded by ice. These are just some of the ways to get there. And you can see up here, that's the traverse that resupplies the station, takes about a week. It comes during the summer, so the summer period lasts for about 3 months at Concordia, which is quite different to other stations. And the traverse comes 2 or 3 times and brings equipment that's been unloaded by the boat in Dumont d'Urville, and then takes about a week to drive at 10 to 20 kilometers per hour, and brings us everything we need. This is Concordia with the 2 towers, and we sleep here. These are the labs. This is the quiet tower. This is the noisy tower. And just a few images to show you what it looks like. Very different light. The light is the most beautiful aspect of Concordia. Changes a lot. It gets incredibly cold and difficult to work outside. This is a telescope I volunteered to help with. Again, regretted my life decisions. And this is the room that we have. So definitely bigger than ISS quarters, absolutely. But in the winter, just picture that this is a double window and it completely freezes out. So you can't see outside. And I thought that was actually quite something really interesting that we probably wouldn't think about being in this environment, what it does on your mental health to never, ever, ever be able to look outside. Because that was the same for all the windows through the station. And if I just go back, you can see how few windows there are, and they're all frozen. So yes, you're going outside, but you're essentially in this very artificial environment. And unlike astronauts, not having the benefit of having the cupola and watching the Earth. And I think that's probably something quite similar to what will happen when we transition to Mars. Other parallels with astronauts on the ISS, we also have the grey water recycling. I don't think theirs is as big. It was a source of constant anxiety. It alarmed at all hours of the day, of the night. And as ESA research doctor, I had to conduct analysis on the safety of the water, which interestingly actually had a lot of repercussions as well in terms of team dynamics. Again, things that you wouldn't think about, but just kind of the safety of the water that you're ingesting, and then the trust that you need to have between individuals on something quite basic as water. So this is kind of setting the scene of what Concordia is and why it's such a good analog for deep space missions to Mars, and why ESA is interested. So these are some of the examples of research I've done. So interestingly, even though we don't have microgravity, a lot of physiopathology or adaptation, maladaptation, if you want to call it, is actually quite similar to astronauts. For example, we get reactivation of latent viruses. So most of you here in the audience will have viruses like CMV, EBV, the kind of childhood illnesses that most of us catch and don't really notice when we're children. But when you are immunosuppressed later in life, these can reactivate. We see that in astronauts. There are things, for example, like cold sores, which can reoccur, and the same is seen in Concordia. So yeah, lots and lots of studies on immunity, but also some on bones, muscles, because although we're not exposed to kind of these fluid shifts and lack of gravity, there's obviously still a lot less activity than you would see in your normal day-to-day life. We were lucky we had a chef cooking for us. You know, you don't have to go shopping. So heaven on earth in some aspects. And then psychological studies as well, diaries, and trying to have, you can see here, that's a platform with microphones over our dining table, listening into the conversations once a week. Very difficult to accept, but trying to gauge whether there were different dynamics of people speaking to different, kind of different subgroups forming through the winter. And then this, I think I have a better picture later, but it's essentially a sim scale Soyuz simulator. That was really, really cool, just getting to play a bit and seeing the effects of skill degradation in such environments. Now, as I mentioned, ESA is conducting a lot of research at Concordia, but is trying to expand the research it does to other stations, because I'll touch on it a bit later. Research in Antarctica is really not easy at all. So I was lucky to visit 5 of the Argentinian stations on their icebreaker for about 2 months. And this was in Orcadas, where they're doing, some of you who do extreme medicine might recognize this, a Tempest monitor, which essentially takes your variables like your heart rate, your blood pressure, your sats, but then has the ability to be connected by satellite to remote locations. And then that was a little video of us testing it and being in direct contact with doctors in Buenos Aires, and yeah, potentially discussing a patient in telemedicine. This is a really, really good paper I recommend. It's getting a tiny bit old. It was only published in 2020, but it's essentially a resume of all the research that's been done at Concordia. It was written by Angelique van Obergem, who's actually the chief exploration scientist from ESA, has a huge background, and yeah, great summary of some of the research that's been conducted. Unfortunately, there are huge limitations. Like Antarctica has the most high fidelity deep space analogues, and we need these, right? Because we're just not finding out enough about isolation and about what happens not only to the body, but in terms of team dynamics, with only, at the very best, maybe not even 20 astronauts at a time up on the ISS. And we've heard how much the time is limited. So we really, really need to find analogues on Earth, and I think my colleagues will speak about other analogues. But there are so many limitations in Concordia. First of all, the biggest one is the subjects, recruitment. You are very much living with your the colleagues who you're doing research, and you're in this very awkward position of kind of being sitting with them at lunch and then knowing that you're going to have to beg them for kind of bloods, or to jump or show their strength or whatever you need to do. So it's a very, very odd balance, and that's quite different because astronauts, I believe, are very much trained to do the research on themselves. There's a huge problem in terms of gender diversity. That has been the case for astronauts as well. I think they're catching up in Antarctica, not quite as much. I did research on myself, but we were 2 women, 11 men. The other woman wasn't included, and so even though I was assured that I could do the research, my data was not published because I would have been an N of 1. And I hoped most of the research at Concordia, because it's such low N numbers, they typically try and get 2 winter overs together. So I was hoping that they could get some more women in, but unfortunately they did not. And then, yeah, motivations are obviously quite different to astronauts. Some of the staff might have no interest whatsoever in going to Mars one day, and so don't really see why they should invest their time. A huge problem is environment, the storage of the samples. We're lucky in that outside is essentially the freezer, so that's quite easy. But then it does make it difficult for the medical doctor. It's huge volumes. You have to think ahead for everything that you will need, and I can guarantee you that's boxes and boxes and boxes of Eppendorf, and then kind of storing all of that and labeling it correctly, and then sending it back and making sure that the cold chain is preserved. So it's really a huge logistical challenge. The data, the equipment, that's improving. So I think they have satellite links now with Starlink. We did not have that luxury. So I spent quite a few nights kind of breaking down data and sending by tiny little packages to make sure that there was redundancy. And then the equipment, you definitely have to learn to be flexible. I think, again, we heard it, the missions from Slavoj, but things will fail. And you just have to be not just flexible, but adapt and find whatever is lying around the station that's been left there just in case. Then there are ethical considerations. As I mentioned, you're doing research on your colleagues and how do you maintain the good dynamics and statistical validity of such kind of low-end samples. So just a few pictures again. That was my lab. So definitely bigger than, although the whole ISS is a lab technically, so maybe mine was smaller. Having to dig out at the end of the winter some of the samples that had been kept. You can see meters and meters of snow. And the good thing, as I mentioned, so there's no freezers in the station itself because outside is a freezer, but it did mean daily trips every morning. I would wake up and get welcomed by the cold to go and thaw or get the samples I needed for the day. A mechanograph, a PQCT, bioimpedance, and I think this year they've even managed to get an MRI scan. We've heard it as well from Shoshana, I think. ESA is really expanding their platforms. They've obviously had the Envy Hub, and there's this Solis 100, so 3-month isolation that's going to start soon. They have collaborations with the Portuguese Navy, with the Italian Navy as well, doing submarine. And yeah, had this really, really good workshop a few months ago trying to learn lessons from research they've been doing. Other Antarctic programs are really trying to draw as much as they can, and I do think Antarctica is just such a fantastic place, and I just wish there was a bit more impetus to really drive the research. So TRISH, the Translational Research Institute for Space Health from Baylor College of Medicine, has partnered with the Australian Antarctic program, and they're doing absolutely fantastic research, including on kind of telemedicine and space medicine operations, and they've had some studies literally in collaboration with Polaris Dawn, to one of the private commercial missions, and really having the studies in tandem. So yeah, a huge potential. And I just wish there was a bit more, we spoke about this kind of governments and political impotence, to really kind of not just do more research, but also have some kind of regulatory oversights and maybe collaboration between all these stations to get the same kind of protocols running across different stations. Quick notes on medical training, because again, I think we can learn so much. The training is very different based on which country you're from and what station you go to. So I was very lucky to have some of the station that the French doctors who go to Dumont d'Urville or the sub-Antarctic islands get. So we had a week in Chamonix. And the French doctors had training, for example, in dentistry. We had a 2-day cadaveric course to do things like emergency appendicectomy if you had to, things like that. But I know the British Antarctic Survey have 6 months of quite extensive training before they leave, including in diving medicine. The Argentinians have a quite different approach. So they have specialists who are not necessarily kind of A&E, GP, or kind of have a wide variety of tools, but then they spend a lot of time doing the team dynamics aspect. So they go and train in their mountains and really get to know the teams and make sure that everyone kind of works well together. But Concordia is a very hazardous station, actually. It obviously gets quite cold. There's an American tower, 50 meters, that the glaciologists have to, and chemists have to go up onto. And there are all these shelters dotted around the station with equipment inside. One of these has a seismograph that's about 50 meters down. And it's quite a nightmare to think how you would extract someone if they fell, and even more so in the dark of the polar night. This is an example of a whiteout that we had, and we had very many of them, actually. And then you completely lost communication when this happened. You technically weren't allowed to go out. So when this happened, I did ask permission to go outside, and it got worse pretty quickly. So I was very rapidly summoned back inside. You could imagine if you lose sight of the station, you might turn in the wrong direction and never make your way back to the station. And my master's thesis actually came from thinking, it's bugging, thinking what to do in terms of medical training for this. It was interesting that I trained the rest of my co-winterers in kind of first aid skills. No one else apart from the other doctor had such training. And on one of the very, very first simulation training sessions that I did, I hadn't told everyone, I essentially did something which I thought as a doctor was extremely simple, kind of simulated twisting my ankle about 100 meters from the station. But we were in isolation by then. I guess my colleagues did care for me. They absolutely, absolutely panicked when I made the call on the radio. The French went one way, the Italians went the other way. They took ski-doos, which they never should have, because it was minus 50 by then, and there was a risk of breaking them. I could kind of hear what was going on, but not everything, and I thought it was a valuable lesson. So I kept the simulation going. One of them exerted themselves too much, trying to get me back in, and then had a bit of a bronchospastic reaction. And so it was really, really interesting to all of a sudden realize that something that seems so simple to me and here would have taken 5 minutes and not really needed much of a debrief actually became life-threatening in that kind of environment. And so I'm really, really interested to try and develop virtual reality simulation trainings. I think there's a lot that exists for surgeon. A lot currently exists in kind of navigation. We've seen it on the ISS. But there isn't much where you're actually having to use your hands and use haptics and really touch the patients and do things like the knotting and the belays and getting someone out of tight spots. What does exist currently is kind of you get to that situation and you get the drop-down menu and you say, this is what I would do. So yeah, in terms of training as well, I think there's a lot that can be done. In terms of here, I think I'll seg more into commercial sector. The Argentinians, it was, as I mentioned, quite interesting to see who they selected as the doctors. We had a kind of, not emergency, but last-minute training to radiologists on how to use a ventilator should they ever have to ventilate someone. As an intensive care doctor, it's taken me years to learn how to do that. So it was interesting that we were kind of trying to teach that in 1 hour. And obviously, hopefully there would be some telemedicine aspect. But I think there is so much to learn in what we're doing in Antarctica to see how we would accompany doctors, or sorry, non-doctors going to these commercial space stations and trying to use telemedicine, remote support. Yeah, running out. Sorry, that was, yeah. And sorry, team dynamics, well, please come in. I'm so sorry. Come and ask me just briefly. It's the biggest challenge, I think, and we need to have a big thing for Mars missions. I'm extremely worried, personally, and slightly frustrated that things that were described in this fascinating book, Madhouse at the End of the Earth, from the winter over on the Belgica, keep happening with people having acute psychosis, lots of sexual harassment, unfortunately. But there are positives that can come out. So yeah, sorry about that. Thank you.
Okay, now we can go to a bit less extreme environment. And Agnieszka and Agata will tell us about the Lunares research.
So we hope that it's less extreme, but still. So welcome everybody. Nice to be here, and that's a great honor. And what are we doing here with Agata? So we would like to present you a topic mirroring the ISS. Thank you. And why are we here? Because we used to cooperate in this facility together. So we used to conduct together some studies in Lunares research station. So this is analog facility simulating social isolation, okay? Because there are different types of isolation, and this facility is concentrated on that. Agata, of course, is head or co-head of this facility, but still she also managed, scientific data gathering. So this is really helpful. But this is our experience. These are my years of studies also, but I have not started from Lunares, and as my previous speaker, I don't know, sorry. So as you said about polar stations, so my background is definitely from polar stations. We have two Polish polar stations, one on north, one on south, and I used to train them before they go. I'm a psychologist, so that's why I was really fascinated when you were talking about, you know, this group dynamic and psychological aspects, because here we are gathered because of medicine, but please remember, there is only one human, and human is body and psyche, and those factors are, you know, interacting. So we should not maybe so separate those two aspects or two disciplines. But Lunares is one facility and one reason why we are here. And the second is AstroMental Health project, which was my great pleasure to be a PI. And it was fascinating journey to be able to conduct studies while Sławos was flying to space. And of course, as it was mentioned by my previous speakers, we are not able to talk about studies when only one participant took part. So of course, we came through all these medical board agreements and what was said before, and we have two participants, so we are very, very happy. And that's why we can talk about AstroMental health. So what we were concentrated on, it was behavioral health, work performance, interaction with nature. And I was once asked why nature, because there is a lack of nature in space. Yes, that is interaction with what is lacking, what is missing. So that is also fascinating. And of course, and what is my passion is also technological environment, because in Concordia also, but definitely in space to the greatest extreme, you depend in 100% of technological performance. So you rely on technology very deeply. So we conducted very comprehensive study. We had really many research goals, but that's not the point today. Today we would like to talk about possibility of creating very precise analog facilities. Because what was mentioned before, Concordia is a kind of analog for space, but we can also build artificial facilities which can help us to conduct many studies. And even it is a little bit easier from an ethical perspective, because people are enrolling to those missions just to perform studies. And when people are going to work to polar stations, it doesn't matter from which country, because we've got really international experience in that. So they are going to make their living there also. They are going for 1 year isolation. And it poses a lot of ethical challenges to overwhelm, to add them to their daily routine. For example, I was really thrilled, these microphones, come on, it's very intrusive psychological study. And I will give the mic to Agata to give you introduction what is Lunares, what offers, yeah? And after that, we will come back to AstroMental health.
Thank you. Good afternoon, everyone. So I wanted to mention, as Agnieszka already started, and as we could hear from other speakers today talking about other analogs, a bit of categories of the analogs existing, and maybe what are their advantages, how they complement each other. So the analog missions are the research tool, and that can be done in different locations on ground. And the main advantages in general are that they are more accessible and affordable than space. That the sample can be larger, and also if we combine the research in those different facilities, the sample gets even bigger. And the environment and conditions can be more controlled and safer, maybe not compared to Concordia and the polar stations or the submarine studies as well. But in general, those analog habitats provide that safer environment. And it also allows us to do a lot of pilot preliminary studies before they go into more extreme locations. And just to compare, like we like to we like to find those categories for the analog habitats to make it more clear for the researchers to know where they want to apply to do their studies. And we can have simulation habitats such as Lunares. So our main focus is to try to mimic also the workload, the schedule, the activities that participants are doing to simulate as close as possible what is happening on ISS, what is happening during crewed space missions. But there are also prototype habitats which focus more on technology and maybe ergonomy. And the good examples are Hera and She habitats that you can maybe check later after the presentation. There are also biotechnological habitats which focus more on life support systems, growing food, and we again have examples of, for example, Eden ISS. And there are so-called adapted habitats, and we put, for example, Concordia in that category because it's something that can function, can have, that was created for different purpose, but now it's adapted, and some of those studies that ESA is doing can also be done there with people basically doing their work and taking care of the station in extreme locations. And I wanted to, oh. I don't know, maybe I clicked something. Okay. Yeah, so this is a lot of text, but I will dive into it because this is, I wanted to present how Lunares fits into those categories. So we are located in the city of Piła in Poland. We started operating in 2017. And the main characteristic is that we are the simulation habitat. We are focusing on crew dynamics. And our strategy is to do, for now, short duration missions, like 2 weeks long missions, multiple time per year, to allow researchers to collect statistical data. And following that, we are trying to standardize our simulations. We are trying to focus on creating the standards for all aspects of the mission, like the routine, the workload, the schedule, the simulated procedures, where we try to create simulated emergencies, simulated procedures of how to prepare and how to do closing procedures for the EVAs. And following that, kind of like indirect support of all of those studies is our main focus with immersion. So we try to make sure that the feelings, the emotions that participants go through are realistic, are real in comparison to the space missions. And so far we managed to do a bit more than 50 simulations, around 270 participants from 45 nationalities. So it's a very diverse group of subjects. And that's also our goal to make sure that the researchers can collect the data from the more diverse teams. Yeah, the age range is from 21 to 49. The background and educational diversity is also very, very big. And one of our focus, one of our niche in those missions is also disabilities inclusion, and trying to work on procedures and solutions for para-astronauts. Oh, it works. I don't know if those slides will be available somewhere later, but I added here a few examples of the research that our research teams finished, that are ongoing. And today I wanted to point out psychology and sociology, as well as space medicine, that it will be on the next slide. So I do recommend to check what are the typical scopes of the studies happening in those simulation habitats. And when it comes to space medicine, we also managed to already collect quite a lot of data with the research teams, especially on how the conditions of the mission, how the simulation impacts, how the stress impacts people individually and in a group, collecting the data before, after, but also during the missions. Yeah, so I think I will hand it over to Agnieszka so she can comment on how we try to do the mirrored mission. So what were the additional steps that we did to accommodate the AstroMental health study?
Okay, thank you very much, Agata. So that was very important introduction, because what Agata described, it was regular work of Lunares, so very regular analog missions. And what we were aiming, it was AstroMental Health project, which has a few aims, and just please let me to go briefly through that aims, and I will go through, I will reach to the analog mirror mission. So what we done with Ignis studies, so first we had pilot studies, so it was regular missions, but with application of procedures which were going to be performed by astronauts in space. And after that, we had a full procedure. So pre-flight studies, the same procedures, psychological procedures on ISS and in more or less the same time in Lunares, and post-flight studies. And this is something very, very much unique. We have no information that any other, research group performed mirror mission in words, so we are very proud of that. And I have also preliminary study results for you today, and it will be the first time we are showing them, so I'm very, very happy that we have it today. But what we done, we collected a lot of basic psychological tests, and also we asked people to collect, to record for us video diaries, which we analyzed qualitatively. So we've got quantitative and qualitative data, and we use all those, programs to process the data. And what I really like, we were not only interested in what people are talking with this qualitative study, but also we were interested in their facial expression, because what we are wishing to, it's our dream, it's not the reality for now. We would like to have a set of parameters which should be tested and monitored when people are flying, for example, to Mars or settling down on Mars, in order to be able to capture their changes in psychological dynamic, to prevent some crises or to introduce in specific moments some specific interventions. So this is a very basic draft of our program. These are 5 objectives which we had. So we were focused on individual predispositions of interaction with environment and technology. Work, definitely people are going there for work. They should be very effective, in that. So we really would like to monitor it. Well-being, of course, because they are also living there, not only working. And what is my favorite topic, these are critical phases. Let's imagine that we will be able to capture this team dynamic and to capture critical phases, whether they exist or not. This is a hypothesis. We've got a third quarter hypothesis, and I'm really fond of analyzing data on that, because I'm not finding any clues that it exists. So that's super interesting. Whether we should have a crisis after the half of isolation, after the half of mission, doesn't matter how much it lasts. So this is fascinating, but it's for next talk. And these are our aims, but this is the aim why we are here today. So this is the meta aim. We were going to test whether, up to what extent, analog facilities can serve as analog for ISS, so as analog for real space mission, because we are doing thousands of analog missions all over the world, but whether collecting data on such a variety sample and on people from so different backgrounds in so different environments are giving us or providing us with data which can be applied to space, because we know that astronauts are highly trained units, they are very qualified, they are very well motivated, and the environment is different. So whether we are maybe misleaded. And what we done, and this is the mirroring, we were doing this mirror mission with a little bit different than Agata described their, general performance. So we were taking into consideration few factors, more than few, a lot of factors. We've been focusing on everything which was able for us to capture through the contact with ESA for 2 years. For example, what was our improvement, and I am very proud of that. We organized analog mirror mission, not only isolating the analog crew, but also isolating the ISS crew, so the background, because when Sławomir and his, Axiom 4 team members joined the ISS, there were different people there, before him. So we've got 2 cruise dynamics. So everything was described, and this paper is going to be published, I hope, not so not so late, but at least soon. But we included a lot of parameters to prepare mirror mission, and here we are going to our scores results, to create mirror mission with the same procedures, with media contact, with the same time pressure, with the same uncertainty that Sławomir faced. So we included, we take into consideration more factors. And look on this very simple data. These are from some really our parameters. Here, for example, this is stress dynamic, and we had multiple measuring points, but here they are, divided in 4 quarters, just to be able also to capture this 3rd quarter phenomena. And when we have a real astronauts, they are here. When we have our mirror astronauts, so those who should have more or less the same conditions, of course, without microgravity or so, in analog. And here, this is our pilot study. So these are analog mission participants without taking care of those external factors. And what we see, that they are, for example, stress fluctuation, it's different than analog astronauts and those who participated in mirror missions so specially designed. So maybe this is the conclusion, that we should really take attention and, take extra care for projecting or designing this architecture of missions, analog missions, to make them as close as possible to space mission, to gather the proper data which can refer or reflect real astronauts' performance. Here you've got negative affect, so the same, we've got even, you can also look on discrepancy here. So the fluctuations here, we've got higher scores, for example, more diverse, more heterogeneous. So if we are not paying attention for recruitation so highly and for other factors, and for this ISS other participants, so we receive very different variety of data. I will go to maybe to this slide. Here are 2 different parameters, job satisfaction and technological well-being. And here you've got only for whole mission, means. And look on that, of course, those who are mirroring, they are not so 100% the same as ISS astronauts. Of course, the astronauts are more highly, professional, they are selected, they are trained. Of course, they are different people, but still, if you look on green path, it's totally different. So the dynamic of those parameters, when we are not paying attention to who we select and what conditions we create, is very much different. So this is the message I would like to leave you with. And just the last slide for military purpose, because why I'm talking so much about these conditions? Because maybe it's not so bad that those green lines are so different, because maybe you would like to apply, analog habitats to shelters, to bunkers, so to different application. And in that case, you will have general society confronted with social isolation. And let's add the war, the crisis, let's add to that extra stressor, which will definitely change the dynamic. So probably for military, service or purpose, you should know how those green people are adapting and how they are reacting in isolation, especially those social isolation, not necessarily these high performance ones. But why I have these 3 papers here, because I was preparing for this presentation, and it appears that there is not so much studies on application of analog habitats to shelters, bunkers, and to everything which, general safety can be interested in. And this is open space for future applications and next studies, and that's also the story about which we can talk in the future. Thank you very much. If you would like to contact us, you know where to find us. It was a pleasure. Thank you.
Thank you. Thank you, Agnieszka, Agata. Yes, thank you for the pointer. And now we're going to hear about the Analog Astronaut Center from Agata and Matt.
Good afternoon, everybody. It's our pleasure to be here, to be invited. Thank you, organizers, for coming here and sharing information about Analog Astronaut Training Center. We already celebrated 100 organized analog missions in Poland. And especially, I think I need to add to all talks before how we can use analogs in completely new dimension that you cannot do on ISS. Something that we need to know in advance to settle the Moon and Mars. So we are trying to organize projects for larger groups that cannot exist on ISS because simply of restrictions of space in the station. So here I wanted to present, of course, experiment just as a case study, but I want also to inspire you that we can organize very interesting projects here in Poland for very low price. Yes, we all are fighting for money to cover our research, and this already takes a lot of money, especially if we are doing medical studies, biological studies. These analyses are super expensive. And if we are still need to develop the mission, to recruit the people, this all is enormous, logistics. So here we are proposing you something that is accessible here in Poland for all the world. Matt, maybe you will say more.
Hello. I would like to tell you some information about our research and educational activities. My name is Matt, and I'm an aerospace engineer, but I'm also instructor in hypoxic trimix diving, and you will see the connection in a second. Both with Agata, we were working at the European Space Agency for a couple of years, and then we decided that we would like to continue our development, the scientific career here back in Poland. So we came back and we started our training courses. We started teaching, and as you can see, these numbers, we already have more than 11,000 hours, and we taught software engineering, what we also taught human spaceflight and some other stuff, to more than 32,000 students. And I think this is a great number, and we are very proud of that. Out of our scientific and educational events, came out of 4 PhD dissertations, 9 master's theses, and 10 bachelor's theses. We have published 9 books, and 1 book is more than 5,000 pages long. So I don't recommend reading it, but it's a huge compendium on everything which is related to AI, software engineering, and stuff. But nevertheless, I would like to tell you a story about 2 suits, and this is the reason why I'm here. First suit is something which we got the permission from the Lem, Stanisław Lem family to use their name for the suit. This suit, I already have this suit here with me. So if you're interested after the talk, we can go to my car. It's in the bag. It's in the trunk. Because unfortunately, on Saturday, I'm flying to Dubai to show this and the next suit that you will see on the next slide to royal family of United Arab Emirates, because they are really interested in whatever we are doing, and we are very proud. But I would love to continue working on those suits, not there, but here in Poland. And to continue further collaboration with Krzysztof Kowalczyk, who was here, but he's not in here anymore. We are working for many years, I would guess 8 years, and you will see in a second suit. So this suit was designed, previous one. This suit was designed with Professor Cameron Smith from Portland State University, anthropologist turned into the suit engineer, who was consulted also by NASA and SpaceX for their suit. So we are collaborating with him for last 10 years or so, and the effect of this collaboration is suit, which is a pressurized suit, and which is a pressurized suit. Yeah, we have two suits, and this suit is designed for, as you can see, the land extravehicular activities, but the primary goal of the suit is the stratospheric flight. And we measured and tested this suit in the hypobaric chamber here at Military Institute of Aviation Medicine, and we took this suit to 10,000 meters, 10 kilometers, 33,000 feet, if I'm not mistaken, more or less. So this is pretty high achievement for us. And I'm very proud of this, that this suit was able to deliver a safe atmosphere in it. Of course, there are some stuff which we need to fix and which we need to work on it, but the suit is already good to go, a platform, and I'm very happy that we are owners of this suit, so Poland has these capabilities now. Please, next one. The other suit is called Order Mark I. So this is the first iteration of our suit, and this suit is also interest of Prince of United Arab Emirates, and also Charles Bolden with the delegation of 5 astronauts to whom we are presenting this suit on Sunday, also in Dubai. So this suit, and this is me here, and I'm very happy about that because I'm an instructor in diving, and this is super cool. To be honest, but the reason here why we came up with the idea of this suit is that through the land suit that we developed, we wanted to move further. Okay, so very nice. You can create a high pressure. You can create a pressurized suit with 2.2 psi, which is it's more or less half of what EMU suit is capable of. But we created one for extravehicular activities for training underwater. And this is a particular interest of mine because I'm teaching the astronaut candidates in the United States. Unfortunately, once again, I would love to do it here in Poland, but for that I need to fly there to United States. And one of the big problems is that the astronauts, before they are sent to neutral buoyancy laboratory at Johnson Space Center, they need to be trained beforehand because NBL is very highly, the schedule is fully packed, okay? So European Space Agency came up with the idea of something which is called EVA pre-familiarization. So they put the astronauts into the program, which mimics and simulates the EVA that they will do and train later on in NBL. But first they need to learn how they operate the tools, how they operate the equipment, how to behave underwater, how to orient yourself in the water, how to use their environment. And this suit is one of the things, which is also, I will be having this suit in Poland on Tuesday, hopefully, so that we can develop it further. This suit is also, we've already agreed with the Polish Naval Academy in Gdynia to do the further research and testing in the suit in their facilities. So as you can see, we would love to work with the Polish Military Institute of Aviation Medicine, what we are doing for last 8 years, and now we are starting with the Naval Academy. Next slide. Oh, and this is Agata.
Thank you, Matt. Yes, so I will come back to the experiment that we performed together in collaboration. Of course, big experiments are never made by a single person. I'm very grateful for my Faculty of Space Technologies that financed all analysis, microbiological, genetical, bioinformatical analyses were done voluntary, sorry. But yes, we were collaborating with SANO, we were collaborating, of course, with microbiology department of Collegium Medicum of Jagiellonian University. This was a huge big project, I would say. And it was just the beginning of the big story that we are now continuing. So first, we had to create this space to run the project. Our question was how people in isolation will affect each other, because we are not only humans, we are carrying several bacteria, several fungi that may influence the health of the crew. And it is not only physiological, health, but also psychological. Many microbiomes affect our mood. So this is really critical when you are in closed group. And again, this can be a dual use interpretation. When you are closed somewhere in the battlefield. Anyway, so our question was how fast microbiomes can be exchanged between the large group. By large group, I mean 29 people. It was 11 women, 18 men. The surface was limited, of course. It was 327 square meters. And we had people from 13 countries, 5 continents, and the mission was 7 days only. So we were only looking at the very fast process. So how many days we need in order to be equal, microbiologically equal. And here you can see the habitat, some sources of biohazard where we were really mixing the bacteria. And the main objectives of the experiment was to determine the dynamics of microbiological changes between our respiratory tracts and the guts during 1 week. So it was this kind of experiment, and we wanted also to see if there are special pathogens that can be detected and if they can be transferred from one person to another, and what will be the transfer routes. So we had to create open space that will provide easy exchange of the air inside. So you can see here the facility. Of course, it is not Star Trek construction. We had no money. This was just private investment. Then we divided all 29 people into 5 teams. And for each team, we created a space, operational space for their experiments. So all teams were moving within the isolated area in a special manner according to the schedule. You can see the gym, you can see some experimental laboratory, and you can see some workshop, greenhouse, and a medical module. As you can see, the crew was interacting with each other a lot. We were using the same suits. Everybody was donning the same suit. Of course, we were cleaning it with water, with some detergent, but not with alcohol. So there was really easy to contaminate each other just by performing EVAs. Then we were using the same VR tools. We were using the same tables, the same plates, the same mugs. Even we were washing them using technical water. And as you can see, we were eating all together, like it is shown on the figure, at the tables. And of course, when we were doing some gravitational research, we were helping a lot of people to provide safety. How we were collecting the samples? So we had 7 days, as you know. T0 was a day that all people arrived to our habitat. First, we took a COVID test just to see if we must exclude somebody to enter the habitat, because this was our definitely no-go signal when somebody got positive COVID test. And then in day 1, day 4, day 7, we collected microbiological samples from nose, throat, and guts. Then we did a lot of analysis. There was, again, microbiological, genetic, and bioinformatical analysis. And 1 month before, in the habitat, when habitat was empty, we were making a pilot studies. We were testing 3 different media for the bacterial growth and fungi growth. And based on this, later we were doing other places. We were measuring 5 sites of environment. So it was a dining place, toilet, workshop, bedroom, and laboratory. For analysis of the upper respiratory tracts, nose and throat, we were using special, media and dry samples for genetical analysis. For guts, we simply used as stool samples. And each astronaut, analog astronaut, received a set of all tools that were used by them, by the crew, to collect all samples. So in this case, each analog astronaut was trained how to make their own sample collection. Beside, we had some complementary monitoring parameters like heart rate, metabolism, temperature, and many, many other parameters. From epidemiological part, we found only 2 people that suffered for chronic diseases. This was made by a survey. I will not go very much into details, but we collected all environmental samples. We collected nearly all samples for throat and nose, but we had problems with stool samples. Many people were too stressed to deliver 3 times of stool samples during such a short period. So we were surprised, and definitely the next colony mission, this is why we are here, we invite you to collaborate for the next colony mission, and maybe this mission will be longer because we see the problem with this part. So we found several phyla of bacteria. Again, I will not go so deep into the details, but I want only to show you that for each analog astronaut, from 1 to 30, we collected a variety of data related to this phyla. And we see how these phyla are changing during day 1 and day 6. The same we obtained for this tool. So we could see the change between different phyla of specific bacteria. The same we did for fungi. And again, we did some dendrograms of the pulse field gel electrophoresis to trace the very characteristic types of bacteria. For example, here we have a pathogen, Staphylococcus aureus, and we see that these bars are different. So these are like the different types of these bacteria. Strains, thank you. Then we did it the same for Escherichia coli, Klebsiella, Pseudomonas. And we found that there is some dynamic of colonization of these strains, Staphylococcus aureus, already within 7 days. We could observe some transfer of pathogens between crew members. And the same for other strains. So what we are searching now, we are searching for some specific species that are easy to be transmitted between one person and another. And what we observed that people with lower inflammatory resistance, they are more prone to be contaminated by these pathogens. So even you are a carrier of pathogen, you do not express anything, any parameters of feeling bad, feeling sick, you may contaminate your crewmate with your microbiome. So this was very interesting. And this transmission was occurring via environment. We were measuring also social interaction between the mission groups. As I told you, the mission groups were working all together. And here is for particular analog astronauts. So we could observe the variety of dynamics between analog astronauts. So you can only imagine how much data we obtained from only one analog mission. How much analysis. Several times already today you said that the mission was just a short period of time, but still we are analyzing the data. We had the same with this mission. It was 1 year ago, and still we are not yet ready done with bioinformatical analysis. Of course, we can see now the different dynamics between the groups of analog astronauts, between each astronaut, analog astronaut, and between where the contamination goes, how the transfer goes, via digestive system or via respiratory system. So all this is very interesting. And here we, of course, observe some changes, but because we kept our samples in the fridge in 4 degrees of Celsius for 7 days, of course, this observation can be caused by the sample storage. So now we are buying a big freezer, minus 80 degrees, in order to reduce this kind of effects. And yeah, here the same. We see some differences. So we are looking now very carefully what is going on. And the main observations for nose, we see increase in Bacillota, decrease in Pseudomonadota. And we see that in the beginning of the mission, we had the dominance of environmental bacteria floating in the air. And later, we see that the bacteria filling the air in the isolation are mostly derived from humans, which is very interesting. The dream would be to draw some algorithm, some digital twin for transmission of a specific types of phyla, at least, to observe what is more, dynamic in isolation, what is less dynamic. And here we can see, yes, how these air samples were changed after the mission. We also show the comparison of methods, because we were using different methods to detect the same parameter, yes, the same culture, bacteria. So we can see that for some our data, we cannot still overlap, and we need to ask more questions and find answers. Yeah, I will close now. So we already can see that even 1 week analog mission, colony mission, can show completely new results for future lunar and Martian bases. And with that, I would like to thank you and invite you for collaboration for the next colony mission with 50 people crew on board. Thank you.
Yes, thank you very much.
Thank you. Thank you for explaining us how these analog mission work. I know we are late, but still I would like us to have a short discussion, because this is a unique opportunity to have you all here. I will ask the first question. So, are you introducing any extra stressors to the people that are in your missions, like to simulate some situation like you mentioned with your knee, or something like this, to kind of provoke them to work in an even harder environment?
In my field, the biggest stressor is underwater environment, which can literally drown you in a matter of seconds. CO2 poisoning, which is a huge problem, especially when we are doing some deeper dives. We need to change to mixed gas environments, and also there's a lot of problems related to that. There's a huge deal related to hyperbaric medicine, decompression sickness, decompression illness, the whole illness, barotrauma. So the reason why we are doing investing in suits, underwater suits, because they are analog for extravehicular activities, and the problems that we have with the suits are exactly the same problems like the astronauts when they go out for on the EVA. So they're going from the environment of the higher pressure inside of the ISS to the environment of the lower pressure inside of the suit, which is 4.3 psi or 5.0 psi with the Orlan suit. So we are exactly adding the same. And the subject participants, they are confronted with the immediate danger of the hostile environment, underwater CO2, which is also gas flow, which is one of our biggest concern. But in my case, drowning and CO2 is the biggest problems that we have.
Yeah, when it comes to the analog missions that we are doing, we mostly, when we are planning any emergencies, the crews are always trained before with what might happen. So we are not introducing any kind of nothing unethical, I would say. Yeah. So there are emergency scenarios that might happen during the simulated spacewalks, but usually the crew members, the participants, know what kind of procedures to follow, and we are trying to replicate the same ones during our missions to learn and to be able to compare the results, the reaction, whenever there are any kind of emergencies that are related to any research, then we are implementing additional scenarios. But it's always done in the way that it needs to be immersive. It needs to be something that is realistic for space missions. But also life happens, so there can be real emergencies now and then, and we need to adapt.
That's a very fascinating topic. I would like to add 2 comments. The first is that when we were introducing studies on ISS, we were, given so many instructions that everything what we are doing from psychological perspective can be a stressor, and we should not add it. And even some of our procedures on tests were, driven back by ESA, not by ESA. ESA Medical Board was super cool, but NASA Medical Board was very challenging, and they, assumed that some of our procedures can add extra stress. And this is something we should not afford for in real space mission, but this is something which can be implemented and tested in analog simulations. So these are those differences and maybe profits in that way. But I would like to relate to your presentation, because this is one of the the biggest differences between analog facilities and Concordia or other polar stations, because you're isolated for real. And here, the safety first. So even if anything happens, you're opening habitat, because it would be unethical. So this is the parameter which we cannot recreate in analog facilities, very crucial to human behavior.
I think if I can just add to that, it's a really nice segue in the fact that at Concordia, it's already such an extreme environment and so intensely, it's in the back of your minds constantly that what's interesting is that actually tiny little things of daily life become huge stressors. To give you examples, as you saw the whiteouts that we had a big antenna outside for satellite communications, internet. We would lose internet when there were whiteouts like this, and it created huge issues and conflict and dynamics, different dynamics through the whole winter. I learnt that the IT technician really suffered from the weight of trying to keep communications through the whole winter. Or a kind of funnier anecdote to actually, we had our biggest kind of fight, I guess, or conflict in the group about washing teacups. Who was washing teacups? And they warn you about that, but it transpired that after hours of discussion that the problem wasn't the teacups. Obviously, it was something else. Or at the end of the winter, we had a whole meeting, like very official, very, very serious. 1 hour, the whole crew was convened because the station leader had noticed that we were probably going to run out of Nutella before the end of the winter. And so we had to convene together, okay, what's our plan? Are we going to just carry on eating it at the same rate as we're eating it? Or are we going to ration ourselves to try and really stretch it? And it, like, you're laughing, I'm laughing, we were not laughing in that kind of environment. Like, people were probably not in this kind of third quarter, but they were tired. We were really, really tired. And that was one of these little things that people were looking forward to, having a bite of Nutella. And it became a huge, huge thing. And you had a camp of people who were for rationing, others who didn't want to. And then it's funny, we had so much discussions. And in the end, I think we didn't even agree. And I think people kind of self-rationed without realizing. And we had plenty of Nutella at the end. So yeah, a storm in a teacup.
I have one more very short comment. Once during analog mission, we had, of course, restricted, limited technical water. We were clearly informing the crew that this is the water that we have for 7 days. It was colony mission, and day 6, yes? Day 6. No. Day 5. Day 5, we open the tap, there is no water. So we say to everybody, somebody was overusing the water. We knew that somebody was taking more water very early in the morning when all the crew was sleeping. So we knew this. And there was a missing water, so it was a real stress. For the management part of the crew, we were really in a deep problem because we were running microbiological studies. We are running out of water, what to do? So we had, of course, drinking water, some supply, and we said that we need now to use this water for everything. And many people, crew members, they simply didn't believe us that this is not a simulation. They thought that we are just simulating lack of water, and it was a real stress for us.
Thank you. Thank you. Unfortunately, we need to conclude, so I will pass the mic to...
Okay. So, thank you very much. I can see still some of us endured until the end of the day, so only the toughest get to the top. Thank you very much for participation in this in today's lectures and in this event. I would like just to inform you shortly, it's a fresh news, I think it's like a few days old. We have created the Polish Astromedical Association. Tomorrow we'll provide you with more details on how you can become a member. And we would all love to see you members and Astromedical folks. Let's gather and let's rock it. And so we meet tomorrow at 9 a.m. Anybody got hurt? Nope. No victims during the day one? That's the good news. Thank you very much and see you tomorrow. Thank you. Goodbye.